Okay, so 2.6 has two topics in it, which are combinations of functions and then composite functions. They're all still functions, and it's basically taking two functions by way of algebraic functions and combining them together with addition, subtraction, multiplication, dividing, and then doing something that's a composite function, which is like taking one and plugging it into the other. So we start with all the things that you can do with a function. You can add to, which means you're literally just adding two expressions. You can subtract them, you can multiply them, so we would like expand and FOIL, and then you can divide, where you literally put one over the other. And then we're going to talk about finding the domain of these functions algebraically, okay, because one impacts the other. So the first examples are just like this. It gives you an f of x, and in this case it's 2x plus 1. It gives you a g of x, which in this case is x squared plus 2x minus 1. And number 1 just says to find f plus g of x. So you're literally taking what f of x is, which is 2x plus 1, and adding it to what g of x is, which is x squared plus 2x minus 1, and then combining your like terms. So I have 1x squared, I have a 2x and a 2x, which is a 4x, and then I have a positive 1 and a negative 1, which cancels out. And that's as simplified as it gets, and that's your answer. You would leave it just like that. I'm going to jump to 3, and then I'll go back up to 2. So 3 says f minus g. So now we're subtracting. So I'm doing the f, which is 2x plus 1. And I'm subtracting from it all of g, which means that minus is going to get distributed to each term. So it changes all the signs. You'd get 2x plus 1 minus x squared minus 2x plus 1. And then you want to combine your like terms. So negative x squared, the positive 2x and negative 2x cancel out. The positive 1 and positive 1 becomes plus 2. Okay, so then when you get to 2 and 4, notice the difference. There's now a value in for the x. So you have two choices here. You can either do what we just did first with the expressions and then take the 2 and plug it in at the end, or you can find f of 2 and g of 2 and add them together. So I'm going to show you both the first method, but then you get to pick from there. So the first one would actually be to find f plus g of x, which we already did. We did that over here, which is x squared plus 4x. Yep.
How did it become x? What did that happen?
The one I just added?
Yeah.
I said you have two choices. One is to find f plus g of x first and then plug in the 2. Or this, so I'm doing the first method, which is treat it as though it's x first. So find f plus g of x first, which is what we did over here. And then plug in the 2. So f plus g of 2 would be take this expression that we already added and then add the 2 in place of the x. And I'd get 4 plus 8, which is 12. So the end result is the numeric value. The other way, yep.
I'm so sorry. How did you solve that equation?
Which one?
Plus,
That's this. We did it over here. We added f of x and g of x. The second method is probably what I would say, unless you already did what we, like unless you had question 1 first and then question 2. If you went straight to question 2, I would probably do it the other way, which is find f of 2 and add to it g of 2. So I'm going to find f of 2. I'm going to take f of x and I'm going to plug 2 in. 2 times 2 plus 1, which is 4 plus 1, which is 5. And then I'm going to find g of 2. So I'm going to take the g and plug in the 2. 2 squared plus 2 times 2 minus 1. 4 plus 4 minus 1, 8 minus 1, which is 7. And then because it was addition, I add the 5 and the 7 to get the 12. So again, if the question does not say find f plus g of x first and then find f plus g of 2, I would normally just go second route. Just take the number, plug it in, and then add them together. So for 4, it's f minus g of 2. I'm going to find f of 2, and then I'm going to find g of 2, and I'm going to subtract the g of 2 from the f of 2. So we already found f of 2, but if I didn't, it would be 2 times 2 plus 1, which is 5. We already found g of 2, but if we didn't, it would have been 2 squared, excuse me, plus 2 times 2 minus 1, which is 7. And then I do 5 minus 7, which is negative 2. Questions on those? So if it's just the x inside the parentheses, you're physically adding or subtracting your expressions. If it's a numerical value in the parentheses, you're plugging it in and then adding or subtracting whatever it says to do. These are both multiplications. So whether the dot's there or they're just up against each other, it means the same thing, right? F with a dot times g, or F against g, both mean multiply. So in the first example, there's an x, which means we're literally just taking f, which is x squared, and multiplying it times g, which is x minus 3. If they were both binomials, I would FOIL it out, but this is a monomial times a binomial, so I can literally distribute it in. So x squared times x is what? X to the third, and x squared times negative 3. Good. And that's it. That's as far as it wants you to go. So now when we go to 6, we have 2 choices. I'm going to show you again. 2 choices. You get to choose which one. The first is we already know what fg is because it's here. X to the third minus 3x squared. And then we can plug in 4. So 4 to the third minus 3 times 4 squared. 4 to the third is 64 minus 3 times 16. 64 minus 48. Which is 16. The other option, and especially if we hadn't already done the work for number 5 like we did, the other option is to find f of 4 and g of 4 and then multiply them together at the end. So f of 4 would be 4 squared, which is 16. G of 4 would be 4 minus 3, which is 1. Multiply them out, and you get 16. So again, you get to choose which one to do. I would say normally I lean towards second method, but it's completely up to you. All right, now it gives you f of x is the square root of x, and g of x is the square root of 4 minus x squared. It says find the combined function and then the domain. So the first thing I'm going to do is look at what's there. The 7 says f over g of x. So you literally just put f in the numerator, which would be the square root of x, over the g, which is the square root of 4 minus x squared. That is f over g of x. You do not need to rationalize the denominator with that stuff. You can leave it like that. But what is tricky here is now we have to find the domain. So you'll either see it say find the domain of f of x, g of x, and then the composite function, or in this case, just find the domain of the composite function. So combined function, sorry. Once we got it into here, now you want to find the restrictions on it. So if I had my square root of x over square root of 4 minus x squared, and I wanted to find the domain, what restrictions do I have to set up? Sophia. Good. Good. So the numerator has to be, because it's square root, it has to be greater than or equal to 0. And then the denominator, I've got a square root in the denominator, which means it can't equal 0 anymore. It's got to be greater than 0. So for my numerator, I get x has to be greater than or equal to 0. But then the denominator, you've got your quadratic and inequality. So we want to solve these as though it's an equals. I would square root both sides doing the plus and minus, and I get x is equal to positive and negative 2. Sophia?
Why did it turn into an equal sign?
Because if it's a squared and an inequality, we have to figure out our test points. So you set it equal, you solve it, then you go to your number line, plot your two solutions. I would plug in 0, which would be in between. And 0 into this would be 4 minus 0 squared is greater than 0. 4 is greater than 0. Is that true? So the bottom would shade in between. And it's not or equal to, so it would be a parentheses on both. That would be just the restriction from the denominator. Yep.
How'd you get the parentheses when you were shading?
Because it's not or equal to. So that's parentheses instead of brackets. And then we plugged in 0 and it worked, so I knew to shade that region. Now I also have my restriction from my numerator, which is greater than or equal to 0. So that would be a bracket at the 0 pointing toward the right. And then this is like an and statement, which means I can only keep where it's overlapped, which is 0 to 2 shaded in between. There was a bracket on the 0, but a parentheses on the 2. All right, so then 8 says g over f, so I reverse it. The g goes in the top, which is the square root of 4 minus x squared in the numerator, over the f in the bottom, which is the square root of x. And again, that's the combined function. That part's done. So now I got to find the domain of that one. I would set the numerator this time greater than or equal to 0 and the denominator greater than 0. I already solved this numerator. The only difference was that it was not greater than or equal to, it was greater than. So I would know it was negative 2 and 2 were my points. I would have plotted negative 2 and 2. I would have plugged in 0. 4 minus 0 is greater than or equal to 0. So I would have shaded in between. And the only difference this time is that instead of the parentheses, there would have been a bracket because it's or equal to. Yep.
When you plug in the 0, what's the answer you have to get in order for it to?
It just has to be a true statement. So this time it's 4 is greater than 0, which is true. Then the denominator says that it has to be greater than 0, which means it's a parentheses on the 0 pointing to the right. And the overlap this time is from 0 to 2 to 0 to 2, but a parentheses on the 0 and a bracket on the 2. So the only difference between these two was the parentheses in the bracket because of where that expression lied, in the top or in the bottom. Questions on those? Domain of composite functions is the hardest part of this lesson. So as long as you can handle it, you're okay. And again, it just takes practice, but it's the same rules that we had before. Okay, so those are combined functions, adding, subtracting, multiplying, dividing. Then we have something called a composite function, okay? Like one of the first years I taught this, everybody kept calling it FOG because it says F-O-G. That O is an open dot for a reason. That does not mean multiplication. It is supposed to be an open dot. So when I refer to it as FOG, it means composite function, okay? And what this means is you go in the order of the letters that are there. You're going to take the letter on the right of your statement, so the one that comes second, and plug it into the one on the left. So f of g of x literally means take my g of x and plug it into the f of x in place of its x. So whatever expression g of x is going to go in the place of the f of x in the place of its x. So if it was g of f of x, now I would take the f of x and I would plug it in to the g of x. Sometimes you're going to have values here and sometimes you're going to have x's, just like we did with the combined functions. So 9 says f of g of x, which says take the g of x, so it could be rewritten as f of g of x like this. The g of x gets plugged in to the x of the f of x. So I get 4 minus x squared plus 2, because this is where the x was. And then just combine your like terms, 6 minus x squared, or negative x squared plus 6. The order doesn't matter. You could have also said negative x squared plus 6. Like, that doesn't order. I mean, that doesn't matter.
Where does the plus 2
From this part of my f of x. So we replaced the x, but the rest of it's still there. You're welcome. All right, so 10 is the reverse, g of f of x. So this time I'm taking the f of x and I'm plugging it into the x on the g. So this f of x goes into the x of the g, which means it is 4 minus x plus 2 squared. That didn't sound good. And then we expand and FOIL that. So this is 4 minus x plus 2 times x plus 2, or use your shortcut, which would be square the first term, double the product, square the second term. And then the negative goes to all the terms after it. And then combining like terms, the negative 4 and the positive 4 cancel out. And I get negative x squared minus 4x. Okay, now look at 11. Now there's a value there. So I can use g of f of negative 2. Which means I'm going to first take the negative 2 and plug it into the f. So I'm going to take my f, which is x plus 2, which is x plus 2. And so f of negative 2 would be negative 2 plus 2, which is 0. And then this whole thing becomes 0, which means I'm finding g of 0. And then I go to the g. 4 minus 0 squared is 4 minus 0, which is 4. And the last answer is your answer. It's not a two-parter. It is the last part. So you're going to do whatever inside the parentheses first, or the second function first. Find f of that, and then take it and plug it into g. All right, you try this. All right, so the first one is f of g of x. So I'm going to take the g of x and I'm going to plug it in place of the x on the f of x. So you'd get 2 times 4x squared plus 1 plus 5. So the 2 still got to be multiplied, the 5 still got to be added at the end. The only thing you're replacing is the x. Now I'm going to distribute that 2x in, so I get 8x squared plus 2 plus 5, which is 8x squared plus 7. Questions on that one? Okay, then 13 is g of f of x. So this time I'm going the reverse direction. I'm taking the f and plugging it into the g. So this whole thing is going in place of the x on the g, which means 4 times 2x plus 5 squared plus 1. And then you can either expand and FOIL that 2x plus 5 squared or use your shortcut. The shortcut would be the square of the first, double the product, positive 20x, and square the second, plus 1. Distribute the 4, 16x squared plus 80x plus 100 plus 1, which becomes 16x squared plus 80x plus 101. Okay, then you get f of g of negative 1/2. So we're going to take the negative 1/2, we're going to plug it into the g, and then take that answer and plug it into the f. You could also, God bless you, if you've already done f of g, just like we did with the addition and subtraction, if you've already done that part, you could just take your negative 1/2 and plug it into that. But more often than not, you're going to go straight to the numeric value. You're not going to do like a 12 and then a 14. So I would say just get used to doing it this way. So first thing I'm going to do is take g of 1/2, negative 1/2. So 4 times negative 1/2 squared plus 1. This is my g of negative 1/2. Would be 4 times 1/4 plus 1, 1 plus 1, which is 2. Then I'm going to take g of negative 2 and replace it with positive 2, which means I'm finding f of 2. And the f is my 2x plus 5, so I do 2 times 2 plus 5, or 4 plus 5, which is 9. And that's your ending answer. So again, the last thing you get is your answer, not 2 parts. Questions on those? Landon. In 13. So because you took the f, right, I took this and I plugged it in to this x, that x is squared. So that whole thing gets squared. Okay, so then another tricky, again, we're back to domain. Another tricky part is the domain of a composite function. So if you're finding f of g of x and it asks you for the domain of the composite function, you have to bring down the domain of the one you plugged in. So the one that's inside the parentheses. No matter what the end result is, you have to include that as part of your domain. So if it says to find f of g of x and then its domain, I'm going to find the domain of g of x, and I'm going to find the domain of my composite, what I get from the combined one, and then treat them like an and statement, okay? Both have to be true. If it said g of f of x, now I'm going to find the domain of f of x and the domain of the composite function, g of f of x, which is the answer I'm going to get at the end. And again, treat those as though they're an and statement. Both have to be true. So whatever is second or whatever's inside the parentheses, that's the one you have to bring its domain down with it. So it will look like this. It says find f of g of x and then find the domain. So if it's f of g of x, which one am I plugging in to the other? Good. I'm going to plug g into x, which means I have to make sure at the end I check the domain of the g of x. That's my added restriction. So I'm going to take the g of x and I'm going to plug it into the f of x. And I get the square root of 9 minus x squared minus 9. What happens when you square a square root? It cancels and I get 9 minus x squared minus 9. 9 and negative 9 cancel and I end up with just negative x squared. Now I would check the restrictions on that one. So is there a domain restriction on negative x squared? What 3 things are we looking for a restriction? Variable in the denominator, variable under a root, or the combination of them in the root in the denominator. Is any of that happening? No. So the composite function has no restriction itself. But because we plugged g into f, you still have to find the restriction on the g and include it in your domain for the whole thing. So if I have that, what's underneath the square root has to be greater than or equal to 0. It's a squared and an inequality, so I would treat it as though it's a equals. I would solve, and I get x equals plus and minus 3. I would go to my number line, -3 and +3. Plug in the 0, because that's the easy one, into my inequality. So 9 minus 0 is greater than or equal to 0. Is 9 greater than or equal to 0? Yes. So the in between works, and it's or equal to, so it gets a bracket. Now, if there was also a restriction on the composite, I would then plot it and see where they overlap. But because there was no additional restriction on the combined one, all I need is the restriction from the one I plugged in, which is the g of x. So the domain here is -3 to +3. This time it says f of g of x. So I'm going to find f of g of x by plugging the g into the f. And I end up with the square root of x squared plus 4. And that's my composite function. Now, is there a restriction on the composite function? Yes. That has a square root, which means the x squared plus 4 has to be greater than or equal to 0. Square inequality again. So we solve. When I square root the -4, is there an answer? No, which means there's no value from this equation that's going to make it negative, which means the domain on the composite is all real numbers. So if you can't find an answer to this, then the domain, then that means there's nothing it can't equal, which means it's all real numbers. Then I go back to the one I plugged in. So I go back to the g of x and say, is there a restriction on that one? Hang on 2 seconds. Is there a restriction on x squared plus 4? No, which means the domain of this entire thing is all real numbers. So you're checking your combined function or your composite function for its restriction, and then you're going back to the one on the right, or the one you plugged in, which is g of x in this case, and look for that restriction. So like on WebAssign and like on a test or quiz, it would say find the composite function, which is the square root of x squared plus 4. That's part of your answer. And then it's going to say find the domain, and that's -∞ to +∞. So like a lot of the questions on WebAssign have multiple parts, and most of them have that domain restriction at the end. So just don't forget that with a composite function, you have to check the domain of the result and also the one that you plugged in. So in this case, the g of x.